Good morning. I'm Regina, Assistant Professor, Department of Mathematics, Rohini College of Engineering and Technology. Today I'm going to explain the reduction of quadratic form into canonical form by orthogonal transformation. So first we can see one problem. Reduce the quadratic form x1 square plus 2x2 square plus x3 square minus 2x1 x2 plus 2x2 x3 plus 6x2 x3 to canonical form through an orthogonal transformation. Find the nature, rank, index, signature. So first we have to write the matrix from the quadratic form. So we have to choose the elements of x1 square, coefficient of x1 square, coefficient of x2 square, coefficient of x3 square for the diagonal elements, and we have to write the x1 x2 coefficient, x2 x3 coefficients and x2 x3 coefficients. So next we have to find the characteristic equation. Characteristic equation is lambda cube minus s1 lambda square plus s2 lambda minus s3 equal to 0. So first we have to find S1. S1 is sum of the main diagonal element. Here the main diagonal element is 1, 2 and 1. So we have to add the sum is 4. S2 sum of the minus of the main diagonal. We have to find the minor of the main diagonal and we have to add this. The answer is 3. The next S3. S3 is determinant of A. Here the determinant is 0. So next we have to substitute S1, S2, S3 in the characteristic equation. So after that we have to get the cubic equation. When we solve the cubic equation we can get the lambda values. Here the lambda values are 0, 1 and 3. The next we have to find the eigenvectors. To find the eigenvectors, first we have to choose one eigenvalue lambda equal to 0. So to find the eigenvectors we have to solve a minus lambda into capital X equal to 0. So we have to substitute the values here. From the matrix form we can get 3 equations. Then next we have to solve any two distinct equation by cross multiplication rule and get the capital X1, that is eigenvector corresponding to lambda equal to 0. Like the same way we have to find the eigenvector for the eigenvalue lambda equal to 3. So here also we can get 3 different equations. When we solve the equations we can get the capital X2. After that find lambda equal to 1. For the lambda 1 we have to find the eigenvector. The eigenvector is capital X3. So finally we have to write the eigenvectors. So next we have to verify the eigenvectors are orthogonal or not. X1 transpose X2, X2 transpose X3, X3 transpose into X1. That value is 0. The next we have to find the normalized eigenvectors. The normalized eigenvectors are given below. The next we have to find the normalized model matrix. So next that is capital N. Next we have to find capital N transpose. N transposes we have to change the row into column and column into row. The next we have to find the diagonal matrix. D is equal to N transpose AN. When we multiply these three matrices we can get the diagonal matrix. D is equal to diagonal elements 0, 1, 3. So the canonical form is y transpose into dy. The answer is 0 y1 square plus y2 square plus 3 y3 square. The rank is 2, index is 2, signature is 2. The nature is positive, semi-definite. Thank you.